So we're adding fractions. Step one to adding fractions, what do you have to have? What do we have to get? Common denominator, yes. So a common denominator. And I heard somebody say least common denominator. And yes, that's why there's an L there. There's just not really room to write that. But technically, even if it wasn't the least common denominator, it would still work. You just be making your life harder, but you know, it doesn't have to be that. And it does say if necessary. Let me just point this out. It is necessary to have a common denominator. You just might not have to get one if you already have one. That's why it says if necessary. All right, and then once we have our common denominators, then we add, because we're adding fractions, our new numerators, but just the numerators. What do we do with the denominators? We leave them alone. They stay the same. You think of them as things. 3/4 plus 1/4 gives me 4/4, right? Okay, so then we put the sum of the numerators over the common denominator. So that's basically what we just said. We leave the common denominator alone. We just add the numerators, put them on top, right? Okay. I know, I'm hoping none of this is surprising news to anybody. Then, if possible, okay? So we reduce a proper fraction, which a proper fraction that we reduce, let's do a little example here, that would be like 6/8 would then become 3/4. Want to make sure you understand the difference between a proper and an improper fraction and a mixed number, all that good kind of stuff. And then this is the step that I don't know that I don't truly believe in this for everything that we ever have to apply this to, but who knows when you might have to do it. So we're going to kind of look at both. But it says change an improper fraction to a mixed number. Okay, so an improper fraction would be something like 7/6. If it's an improper fraction, numerator is bigger than the denominator. To change it to a mixed number, 6 goes into 7 once with 1 left over, so 1 1/6 would be another way to do it. To me, even if you're cooking, not that you usually use like a 1/6 of a cup, but if you have like a 1/6 of a cup measuring, you might just measure out 7 of them. So this one might actually still make more sense. But so like I said, we're gonna do a couple of those just to make sure we all understand the process. I think sometimes you also just get some processes confused. Some of it has to do with the cutesy names that you're given when you learn this stuff, and it's not like the real names. But also things like cross-canceling and cross-multiplying, those are completely different things, which cross-multiplying probably should never be taught like it is, but it is, and we can't control this at this point. All right, so let's do some examples, okay? It's going to be the hardest thing you've done all day. 2, what will my common denominator be? 9. So I'm going to leave the first one alone, 2/9 plus 3, right? So it gives me 3/9, and in the end I get 5/9, okay? And my intention is not to insult your intelligence either. If you are sitting there like with your eyes rolling back in your head, like sometimes we need to practice these things and it's okay. Okay, so then we have 7/8 plus 1/6. Now, one way you can do a common denominator is you can literally just multiply them together, and we could use 48. That works. That's not the least common denominator, probably not the best way to do it, but it works, okay? But what do you think the least common denominator would be? 24, okay. So if it's going to be 24 and something that would help you, I'd have to multiply 8 times 3. So like maybe you want to put the 3 times 3 there, and maybe you want to put the 4 times 4 there. That's totally up to you, okay? Like whatever your needs are. So then that's going to give me 21 over 24 plus 4 over 24. Does my denominator become 48 now? No, it does not. We are adding, so the denominator stays the same, and this gives me 25 over 24. which really I'm fine with you leaving them like that, because most of the time when you're dealing with fractions mathematically, if you've got to substitute it back in, you don't want a mixed number. So, but if your expectation is to get a mixed number, then 24 goes into 25 once with 1 left over, and you get 1 and 1/24. Okay. Any questions at all? All right. What do you think you want your denominator to be for C? 12, okay? We could use 24, but 12 works too, and it's better, I think. So that means I'm multiplying this one by 2 over 2, this one by 3 over 3. So that's going to give me 22 over 12. And here's the let me write this down, plus 15. I don't see it so much after I stopped teaching freshmen, but I would see students do this, get a common denominator, and then in the next step, reduce it and just start going in circles. So don't reduce it. You just did that on purpose, okay? So you just kind of get lost in the circles here. All right, so my denominator is still 12, and that gives me, what, 37 on the top? All right, which again, we could leave like that. But how many times does 12 go into 37? 3, okay? And with 1 left over, okay, so I heard, and that's okay, I don't know who I heard it from, I heard twice, okay, so let's say that you do that, because that's definitely, it does go in there twice, but if I do that, and I say 2, so that's 24, well, 37 minus 24 is what? 13? This will give me 13/12. Then when you get there and you realize, oh wait, that's still an improper fraction there, you got to take out 1 more 12th. I mean, sometimes it happens in more than one step, and that's okay. There's nothing wrong with that. Okay? I like it when I hear wrong answers sometimes, because sometimes y'all don't say them. You think them, and then you're confused, and nobody ever says anything to me. Any questions at all? All righty. What's my common denominator here? 20. So we're going to leave this one alone, multiply this one by 2 over 2. So I get 6 over 20 plus 10 over 20, which gives me 16 over 20. That's not an improper fraction, but can I reduce it? Yes, and sometimes we reduce things like in steps. So you can think about it as, what's the biggest number I can divide in there? And that's fine, and sometimes that's obvious to you, but they're both even. So I can also just say, okay, that becomes 8 over 10, and then I can reduce that again and get 4 over 5. Okay, so you don't always have to do everything in one step. I think that's another problem sometimes, and then you get lost in the crazy scratch work everywhere. That's not necessary. Okay. All right, so now on E, when we have to add a mixed number to a fraction, you do not have to, you could change the mixed number here to an improper fraction. You could do that, but you don't have to. So let's not do that so that you can just see another way to do it. I can't completely ignore that 3, but I'm going to ignore it for a second. When I'm just looking at my fractions, what would my common denominator be? 10. So I'm going to multiply this fraction by 2 over 2. Right? I'm going to out front. And this is going to give me 3 8/10 plus 7/10. Okay. Then I'm going to keep the 3 there, add my fractions. So this is going to be 3 and something over 10. Well, 8 plus 7 is what? 15. Okay, and then I can reduce the fraction part, right? The 3, he's just along for the ride. So 3, I can divide both of those by 5. So this becomes 3 3/2. Now this is where you would absolutely not leave it like this. Like a mixed number, okay. An improper fraction, okay. A mixed improper fraction, not okay. So this is kind of like this reducing that we just did. Why does my board hate me? Like we just did here. Same type of thing. So I can reduce this more. So 2 goes into 3 one more time. So I'm going to add that to that 3, and that's going to become 4 1/2. Okay. Or I could have made it into an improper fraction and done 3 times 2, which is 6, plus 3, or it could be 9/2. Either way. 9/2 or 4.5 are the same thing, okay? And again, not knowing what your expectations might be that's coming, we just need to understand them both, okay? Any questions about any of that? Can we add fractions like champions? Yes, we can. All right, let's talk about subtracting fractions. Sorry, mine's set up like your book is. Okie dokie. So, subtracting fractions. Guess what? Most of it's pretty much the same as adding. We get a common denominator if necessary. Now again, it's totally necessary to have one. It just might not be necessary to get one if you already have it. Then, since we're subtracting, we subtract the new numerators. We leave the denominator alone. Then we are going to put the difference, we're going to sound fancy here, difference of the numerators, the thing you just subtracted, over the common denominator, because the common denominator stays the same. And then you always simplify if possible. And again, it's reducing a proper fraction and change an improper fraction to a mixed number. But again, it's kind of a matter of opinion. And there you go. Okay. All right. We're all good? All right. I'm hoping this is semi-easy for you, and that maybe if there was any part of any of it you didn't make sense to you, that we can make it make sense now and we won't struggle anymore. All right, so again, we have a mixed number and a fraction like we just did. So that's fine. We're just the 3's one for the right again. What would my common denominator of the fractions be? 8. So I'm going to multiply this by 2 and 2 here. So 3 1/8 minus 6/8. Okay, well here, we got a couple of options of what you could do. I don't know that I would get a negative fraction. You can borrow one from the 3, or you could just change it to an improper fraction. Like since this is less, if I was adding it wouldn't matter, but since this is less and that would give me negative, I don't want to go there if I have a mixed number in there. Borrowing is fine. That's kind of how it shows you. And again, maybe this is why we all get so confused when we first learn this stuff. I personally think we should just change it to an improper fraction. Doesn't that make more sense to you? To me, that makes more sense. So we're going to change this, which we could have at the beginning, but if it wasn't, we would need to. So I'm going to change this. And to do that, we do 3 times 8, which is 24, plus 1 gives me 25 over 8 minus 6 over 8. What's up? Are you here because I forgot about you? Because I didn't forget about you. No.
For the letter recommendation, I kind of just like
perfect.
For
okay.
Everything.
That's great.
That relates to the.
Yeah. Awesome. Okay. Yes. Awesome. Just go put it in the middle of my desk. Okay. Do what? Yes. Oh, here. I don't want to forget. This is for you because I got a last period. All right. So now that I have this. My denominator is 8. What is 25 minus 6? 19. So we could leave it as 19 over 8, but I can read, how many times does 8 go into 19? Twice, with how much left over? 3. It's okay. It's okay that it's not instant. We can think. We can use our fingers. We just got to get it right. We're fine. We good with that? So that's an instance where you would want to change it to an improper fraction. But again, you don't necessarily have to. You could wait and see if you need to, or you could just do it, whatever you're more comfortable with. Okay, what would you make your common denominator on B? 20. Okay, I think I'd go with 20 also. So this is going to be 4 and 4. It's going to be 5 and 5. So this is going to give me, oh, not 20. It's going to give me 16 over 20 minus 10 over 20. Right? And that gives me 6 over 20. Am I done? No. They're both even, so I can make that 3 over 10. Am I done now? I'm done now. There's nothing else I can do. We all good? All right, so on C, do we want to wait to see if we need an improper fraction, or do we want to just get them? All right, we'll wait then. You're not going to answer me, I'll just make it up. So, because I think you're used to doing it that way, so I'm thinking maybe you need to see it a different way. So if I just look at my denominators, what would my common denominator be? 12. We could use 12. So this I'm going to multiply by 3 and 3, this 2 and 2. So this is going to give me 2 and 9/12 minus 1 and 2/12. Here, because when I subtract the fraction part, the numerators, I'm not going to get a negative number. I don't need the improper fraction. I'm going to subtract my whole numbers. 2 minus 1 is 1. 9 minus 2 is 7, so it's 1 and 7/12. Any questions at all? Okay. So let's talk about D and what this elementary school lesson is telling me to do, which, again, no wonder people get so confused. Trying to borrow from the 8. We don't need to borrow. We're just going to make it into an improper fraction. So we have a whole number. We're putting it over 1 to make it into a fraction. Now that I've done that, what is my common denominator going to be? 5. So that means I need to multiply this by 5 over 5. So this is going to give me 40 over 5 minus 3 over 5. And that gives me 37 over 5. How many times does 5 go into 37? 7. So we got 7 with 2 left over. So let me just show y'all what it really says to do. It says to take that 8 and change it into 7 and 5/5 minus 3/5, which makes sense because we're kind of borrowing 1 from there, but then that's going to give me 7 and 2/5. And like maybe that's faster, but I could totally see how that borrowing thing can mess with your mind. I think just improper fractions better. Yeah, even when I looked at it at first, I was like, what? And then I'm like, it makes sense, but why would you just know? I know. It's wild. Okay, so what do we want our common denominator to be on E? 30, okay? And again, if 30 doesn't occur to you, 60 is fine. The numbers aren't going to be that big. I mean, you could deal with it. You just have to reduce it. But we can do 30. So this is going to be 3 and 3, 5 and 5. Y'all go ahead and do this one all by your little selves. All right. How are we feeling about that one? Wait, oh, I turned the page. Wait, why didn't I get the right answer? No, I'm looking at the wrong question. And just because let me back up so I haven't confused anybody. When I told you up here, when I subtract these, since I'm going to get a negative number, that makes me stop and want to do this. And none of these, if I was subtracting this backwards and it actually gave me a -7, that's okay. You can have a negative answer. You just don't want that negative to be in the middle of a mixed number because then that makes things weird, okay? So negative answers are okay. I'd originally thought, okay, maybe we'll stop with addition and subtraction one day and do multiplication division the next day just because, but you're all here, so we're finishing because I don't want anybody to not show up tomorrow because I need you to hear all this stuff. Okay. So congratulations, we're moving on. Okay, now when you multiply, you see, here's another reason why I kind of like when you're adding and subtracting to always change it to an improper fraction, because that's a rule for multiplying. I feel like if all your rules were this kind of consistent, it wouldn't be that big a deal. You can't leave a mixed number and multiply without it being, I mean, you could, but you don't want to. So we're going to change all mixed numbers to improper fractions. Okay? And put whole numbers over 1. Basically, we're making our whole numbers into a fraction like I just did with that 8 a minute ago. So then the second one, number 2, we are going to cross cancel if possible. And this is a step that a lot of people skip, which makes the whole multiplying thing worse because it makes your numbers big and then you have to reduce big numbers. But I think maybe you skip it because you've never really understood it. I mean, maybe that's it, or you're getting it confused with cross multiplying. I'm not sure. And then here's the important part, because it's not multiplying. We multiply straight across numerator and denominator. Straight across, both of them. So numerator times numerator, denominator times denominator. And then the end is the same as the other ones, that we are going to reduce proper fractions. I mean, technically, you're reducing the improper ones too. And change improper fractions to a mixed number, which is hard for me to write because I've spent so many years going, don't ever do that. You only do it for cooking, so maybe we won't when we multiply and divide. It's just bad practice because weird things happen. All right, so do I need a common denominator? No, I do not need a common denominator. If you get a common denominator, it's not going to hurt anything. It's just going to make your numbers big and ugly. I don't have any mixed numbers. I don't have any whole numbers, so I'm literally just going to multiply straight across after I cross cancel. Okay? So to cross cancel, that means this. I'm not cross multiplying 1 times 5, 4 times 8. If you ever do that, it's cross equals. You're reducing things. So 4 goes into 4 once, goes into 8 twice. The 5 and the 1 I can't reduce. So now my new numerators are 1 and 1. I multiply 1 times 1. My denominators are 5 and 2, and I get 1/10. Now, I could have multiplied straight across and gotten 4 over 40, and then that becomes 1/10. Like, that's the same answer, but sometimes your numbers get really big and yucky. Okay? So it's just better for you. Well, good. Did I do something wrong? Oh, this is why we're confused about this stuff. Okay, let me back up. Wait, I didn't do anything wrong, though, did I? Just confused you, but that, okay. Okay, I'm just making sure. Sometimes when y'all look at me like that, I'm like, oh my God, what did I do? Okay. All right, let me back up and let me re-say what I said then. Okay. Here, this is where we're confused. See, I figured it out. Okay. All right. So cross multiplying. Here, let me do this. Don't write this down because I'm going to erase this. If I had, which I don't, so do not write this down. If I had 4/5 equals, I don't know, x over 8 or something like that. This is when you were taught to cross multiply or do the butterfly, which again, there's other ways to teach it where it wouldn't have confused you. We would do 4 times 8 and get 32 equals 5x. That's cross multiplying. You do it across equal signs, okay? You cannot cross cancel here. I cannot reduce the 4 and the 8. There, that makes no sense. Here, I'm not multiplying, so I'm not multiplying 4 times 8 and 1 times 5. Here's how we're gonna write this out separately. Here's what we're gonna do. No, let's just rewrite this. 4 times 1 over 5 times 8. We're just gonna make it into one big fraction. Okay? Just what you could totally do with that too. Okay? Now that it's one big fraction, I think the whole canceling thing isn't as confusing because it's all in one. So now the 4 and the 8 I can reduce, right? I'm reducing it, pretending like I have 4/8. Oh, I did make 4 to 1. Yes, okay. Well, yeah, because what I did, I said 4 goes into 4 once, 4 goes into 8 twice. That's what I did. I'm reducing the 4 and the 8. 4/8 reduces to 1/2. Does this? Okay. But again, and I do think, okay. Oh, no. Okay. Okay. That's all right. I get why I need to restate things. So what I'm doing here, and we're going to write it this first time. It makes sense. But if you, I know y'all, and I know you're not going to rewrite things every time. I just know you're not. But what you can do is you can make it into one big fraction like that. Think about it like this. We're now reducing. I can either, if I can reduce the 4 and the 5, that's great, but I can't. But I can reduce the 4 and the 8. 4 goes into 4 once, goes into 8 twice. And then when I multiply that, that's where I get the 1/10 from. Okay? Does that make sense? Thank you for speaking up. Speak up again if I need to restate it again. Okay, even if you didn't first learn it, like somebody should have taught you somewhere. Oh, American education system stresses me out. I want to hear these things. Okay, well, no wonder we all struggle so much. No more trauma. We're going to fix, I'm here to fixing trauma. This is fraction therapy, okay? Which also tells me that maybe when we added and subtracted, we have just gone ahead and made these into improper fractions so we don't start making up math. Because here you have to. I cannot leave them like this. I do not need a common denominator, but I cannot have mixed numbers. So I'm going to change 2 and 1 6. I multiply 2 times 6, that's 12, plus 1 gives me 13 over 6. Okay? 2 times 5 is 10, plus 2 is 12 over 5. Did I hear a huh? Okay. Where do we get what from? 6 is the same as 13. 2 times 6 is 12. And then, okay, that's where I got it. We good? Call it Texas? I don't know. See, that's the problem with the cutesy names. I had a girl in geometry one year that swore to me she never learned something. I don't even remember what it was. Let's say it was systems of equations. I was like, I know who your teacher was. I know that y'all learned this. Like, I understand if you don't get it, but you can't tell me you've never. I was like, would you please tell her? She goes, oh yeah, just tell her Titanic. I was like, Titanic? I remember Titanic. I have no idea. No wonder they don't know what I'm talking about. So, but do we all understand how I got these two? Yes? No? Are we good? I feel like I'm on the Titanic. I know. We're going down fast. Okay. So now, I'm going to make it into one big fraction, and I'm multiplying these. Now, 13 is not going to reduce with anything. But 6 and 12, can I reduce that? 6 goes into 6 once, goes into 12 twice. I can't reduce with anything. So multiplying 13 times 2, which is 26, and 1 times 5, which is 5. I should have started the year with this, huh? Okay, so let me tell you, because what you're telling me is what you learned is to multiply them and reduce. You can do that. What is 12 times 13? So we're here, 13 over 6 times 12 over 5. Yeah, exactly. Okay? I'm not even sure. It's 144 plus another 12, right? Is it 156? So I'd get 156 over 30. I'd have to come up with that. Then I'd have to reduce that to get here. Yuck. Like, do you see how much easier it is to reduce? I've been doing that crap all year. Not a single one of y'all understood what I was doing. Good Lord. I'm going to start the school year every year, no matter what I teach. We're learning fractions to begin with. So yeah, to me, this is yuck. It works. And if you have a calculator, fine. But if you don't, all right, you don't always want to be reliant on one either. Like we need, we can have little thoughts up here. All right, are we good? Wow. You go home and be like, what'd you learn today? Oh my God, I learned fractions. It's so exciting. You're going to feel so much better about this stuff. Okay. So now I do not have mixed numbers. I do not need a common denominator. I'm going to do one big fraction here. Multiplying. Let's reduce some stuff. Can I reduce this 7 with what? to 14. Goes into 7 once, goes into 14 twice. Use your own numbers of your work. Then I can reduce the 10 and the 30, right? 10 goes into 10 once, goes into 30 3 times. I multiply straight across and I get 1/6. Otherwise, I'd get 70 over what? I don't know, 312, something like that? That is an excellent question. And honestly, y'all, I'm learning a lot. I had no idea everybody was this clueless on this. I don't mean that as a mean way. Like, had I known, I'd start fixing this stuff a long time. Like I told you, I review this stuff, but I don't teach it from scratch. And I felt like this is what we need to do so we can figure this stuff out. I'm learning a lot. Now look at this nonsense, right? This I know. No. Okay. And we can multiply all this. And here's where you can't get lost in your own work. Because this is not difficult. It looks yucky, and I know you hate it because I know you hate fractions. But, so we're going to start. I can cancel this. I can also just cancel my 4s out, right? That's fine. Can I reduce this 12 with anything? This 6. So 6 goes into 6 once, goes into 12 twice. So now 2 goes into 2 once, goes into 8 4 times. Circle them so we don't lose them. My 1 and my 1. And the denominator have 25, 1, 7, and 1. Okay? So depending on your handwriting and how, I know some of y'all, even with decent handwriting, you write so small, I don't even know how you keep up with anything. So it might not be a bad idea to circle what you're doing so you don't pick up wrong numbers. And here's the catch here, which is a good catch. If you have completely reduced everything you can reduce now, when you multiply it, you're not going to be able to reduce anything else, so you don't even have to try. Like if they're obscure numbers and you're like, I don't know if they do. If it's completely reduced right now, then it's completely reduced. We just need to multiply. Oops, let me get out of the green here. And I'm going to do 4 times 3, which is 12, times 1 is 12. The 1 and 1, I'm really just multiplying 25 times 7. If you're multiplying 25 by a number, don't go off think about quarters. You got 7 quarters. How much money do you have? $1.75. Yeah, so it's $1.75. And that is your answer. We had chosen the 8. Okay, so let's look at I'll do that in a different color. How's that? Like if you had chosen the 8 with the 4. And I would get the same answer. So it doesn't matter. I just think, let me back out my blue stuff. And let me tell you the reason I think that that's probably better, like if you can just completely cancel a number, is because like here where we got the 2 and then we did it again, if you keep and you can do that a few times if it was still a number that you needed or that you could cancel out, and that you can get lost in your stuff. Whereas if you just cleanly cancel something out, it just makes less just your own, but it wouldn't be wrong. You should get the same answer. Very good question. What else we got? All right. Well, I was going to tell you, well, go ahead and do E on your own. Can you reduce anything? No. That's a really easy one for you to do. So it's 2 over 45 and you're done. Okay. All right, so here's your challenge today. I want you more than anything to practice. So there's practice problems at the back. Practice the multiplication ones. Ignore the division ones because we'll do that tomorrow. But division and multiplication kind of go hand in hand. So now that you've got all this knowledge with your multiplication, practice that so you got it down so that when we divide tomorrow, it's going to be a piece of cake. Okay? I'm so proud of y'all. Look at you.